Okay, class. So today we're going to be doing the last chapter in this course, which is chapter 16, which is titled Radical Expressions and Equations. Section 16.1 is the introduction to radical numbers. A radical number is pretty much a number that's inside of in this case inside of a square root symbol. So the little funny looking hat house type of symbol here, that's shown over the x to the second power, that's the square root. And a simple definition, or one of the definitions that is commonly used for the square root, is for any real number, in this case x could be any real number, the square root is the absolute value of a, or x in this case. When I was writing my notes, I just I used a instead of x. So it's the absolute value of x. So the square root, by definition of absolute value, will always be a positive number. For the sakes of this class, it will always be a positive number. You can never have a negative inside of a square root. That will get us to imaginary numbers, which again, as I've mentioned in the past courses, or in past videos, will be handled or be dealt with in more advanced math, such as trigonometry, or even algebra 2, or even calculus. But again, for the sakes of this class, remember that the square root, inside of the square root symbol, you cannot have a negative number. So how do we go about obtaining the square root of a number, or finding out the square root of a number? The way that I always would tell my students is the following: if you have a number inside of a square root, find the multiples, the even multiples. So in this case, the x splits into x times x. So as you can see here on the right hand side, I have expanded the x to the second as radical or square root of x times x, right? So now here is the layman's terms on how to solve for the square root of x to the second power. Per every two numbers or variables of the same, one of them is going to be simplified out. So for example, here we have 1x, a second x, it comes out as an x, it gets simplified as an x. Okay, that is just the rule. So for square roots, if it doesn't have, one thing to point out also is that if it doesn't have a number, an exponent here in this region, it automatically is a 2. Again, right? So that's why we're saying per every two of the same thing, one of them is going to come out and is going to get simplified. You will see in future lessons in the book, we're not going to cover those. I can do an example if you guys would like of there are cases where they'll have the cubic root. In that case, per every three of the same number or variable, one of them is going to come out. That's okay. But for the sakes, again, for this lesson, for this chapter, we're going to be looking at x to the second power, or the square root, which is only 2. So let's proceed in looking at another example here as to how to simplify a square root. Let's take the square root of 25 again. We simplify it into what are the multiples of 25, which is 5 and 5. So we continue here as 5.5 times. I don't want to get confused with the x. So again, per every two of the same number, one of them comes out, and we can say that the square root of 25 is 5. Now keep in mind also that there are going to be some instances where the number will not be an even, the same number will not be able to be simplified exactly. So for example, let's look at this example here with 8, the square root of 8. So we break it down as the multiples of 8, right? So we have 2 and 4. We can continue simplifying this 4, right? So this is 2 times 2. Okay? So now look, 8 is the same thing as 2 times 2 times 2, right? So again, we said that per every two of the same number, one of them is going to come out. So look, 1, 2, it comes out of the square root symbol, and the additional 2 here that doesn't have a quote unquote a partner to come out of that square root with will remain inside of that square root symbol, and therefore your answer will be 2 square root 2. Now you might say, okay, well, how can we use the square root of 2 in a calculator? You can, but keep in mind that if for example, if it gives you 1.7491214 and it gives you some more numbers, by you rounding off, you will not be having an accurate answer. So this is the best answer possible whenever you have a radical 2 instead of simplifying it. Okay, so that's how we would do in simplifying square roots. Okay, so as I mentioned earlier, there are ways to use a calculator, I mean, which is totally fine. I am not one of those professors that will say, no, 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 it's, you have to learn everything to solve every problem mathematically. Do not rely on technology. No, it's perfectly fine, but this is what I was explaining to you earlier. For example, the number 7, there are no two numbers that there is no one number when it's multiplied by itself that will give you a 7. If you use a calculator to take the square root of 7, it'll give you 2.645751311. For the most part, we always work with 3 significant figures. So the little squiggly equal sign here means approximately. So we're going to round off to 3 significant figures here, which is 1, 2, 3. Remember that whenever we round off, we look at the number behind it. If it's a 5 or higher, the number that's underlined becomes 1 more. If this number was 4 or lower, it would just become a 0, and that number remains the same. So it's an approximation of 2.65. Now, if you were to multiply 2.65 times 2.65, you would get something that looks like very, very close to a 7. And again, as I mentioned earlier, if you're not able to solve or simplify the square root by multiplying a number or times itself to give you that number inside here, then your best answer is to leave it as radical 7 or square root of 7. Okay, now since we're dealing with algebra here, we're going to have to introduce variables, right? So in this case, we have the square root of a monomial xy raised to the second power. So think about it. This is the exact same thing as if we had x times y times x times y, right? Because this exponent to the second tells you that there are 2 of these items that are here inside the parentheses. So for the sake of simplifying now, again, let me erase this here a little bit. Now I usually put a little line here. Some of you might be wondering why I put that line here. That way I know which numbers up to where that square root symbol encompasses. I don't want to put a times a 4 here and have me thinking that that 4 is also part of the inside of the square root. So that's why I put the little line here, just for my own sake, so that I won't get confused. You can do that if you want. If not, I have no problem. Okay, so then again, if we were to follow the same example as before, per every 2 of the same number or the same variables, in this case the same groupings, per every 2, one of them is going to come out when it gets simplified. So there's one xy, a second xy, so it cancels out, and your answer is just xy. Okay, now let's look at this other one here. We have the square root of x, y to the 4th power. Again, we do the little square root symbol here, and let's expand or simplify this. You can do x times y to the second times y to the second, or if you want to do x times y times y times y times y, it's the same thing. Okay, what I want to illustrate here is that if you know you're able to simplify a number or a variable into two equal parts with big exponents, don't continue expanding it further, because pretty much you'll be wasting time. Especially this is handy, especially when you are working on a standardized test. So let's work with the top one here. So we have x times y to the second times y to the second. Again, to simplify it, we look at are there two of the same x within this square root symbol? No, there isn't. So that x will remain inside by itself. Now let's look at the y's. There is one y to the second here, a second y to the second. In order to simplify it, we just cross them out, and one of those components comes out. So your answer would be y squared times the square root of x, and that would be your answer here. Okay? If we were to proceed in this manner here with the completely expanded version of it, it's still the same thing. Look, so one y with a second y comes out, and one y with another y comes out, right? To simplify it, you multiply them here, and we said that the x will remain inside because it doesn't have an extra x to be simplified with. So here we have y times x, square root of x, which is the same thing as y to the second square root of x. Okay, so this is more expanded. This is a little bit I guess you can say a little more mental math type of a method of solving it. Okay, so here we have a section 16.2, which deals with multiplying and also simplifying radical expressions. So I have a few examples here that I'm going to go over with you so you can see what I mean by that. When you multiply two variables or two numbers that both of them are inside of a square root, it is very safe to multiply whatever terms are inside of it and place them both together under a square root. So for example, in this case, we're multiplying a times b, so your answer would be ab, right? Which this implies multiplication or a product here, and it'll be under the square root, and then you would proceed in simplifying that square root of, or taking the square root of whatever product is inside of it. So for example, to illustrate that, what I mean is this: we have 4 times the square root of 93. So here we have 4 times 93. We can say it as so here we're going to multiply, or we can just pretty much solve it this way. Look, we know that we're going to multiply and eventually simplify it, right? So here what we can do is we can just break down that 4 into a number that multiplies by itself to give us that number, which is 2 times 2. And then we know that there isn't a number that multiplies by itself evenly to 93. The closest one we can do is 9 times 9, which gives us 81. And the next one will be 10 times 10, which gives us 100. Okay, so we know that 93 would be between multiplying a number by itself between 9 and 10. So we're looking at about 9 point something. So if that's the case, then we can just do 93 here and proceed in simplifying. I'll put it here this way. So our answer would be 2 square root of 93. And that is your answer here. I'll put a little equal arrow here. Okay, so you're kind of getting the idea of how to simplify that. So now let's continue practicing that. So here we have another example of 63. So here we gotta break down or simplify that 63, and it could be 3 times 21, or it could be 9 times 7, right? 9 times 7 gives us 63. This y to the third power is y times y to the second. Can we continue simplifying this 7? no, it'll just be 7 and 1. Here it would be 3 times 3, right? Sorry. And then on the right hand side here, that y cannot be further simplified. So now we need to break down this y to the second as y times y. So now to bring it all together, as we did in the previous section, we have how many numbers here? We have 3 times 3 times 7, right? So 3 times 3 times 7. And how many y's? We have 1, 2, and 3 y's. So y, y, y. That's a y, not a 4, sorry. Okay, so again, for every two of the same number or the same variable, one is going to come out. So we have 1 and 2 threes, one comes out. We only have 1 7, that stays in there. We have 1 and 2 y's, one of them is going to come out. So our answer would be 3y times the square root of 7y, and that is our answer here. Now, just when you were getting the hang of it, algebra likes to throw you a curveball. Remember that. So in order for us to simplify this trinomial, first we got to do, remember this, don't you love it? Right? We got to simplify that trinomial. So we said that we look at the second sign. If it's a positive, both parentheses are going to have the same sign as the first sign. So here we're going to have x plus, and now we got to look at the multiples of 49. So what number times itself gives you 49? If you said 7, you are correct. Right? So this x squared plus 14x plus 49 simplifies as x plus 7 times x plus 7, and we apply the same concept in simplifying. For every two of the same item, number, variable, or monomial or binomial, one of them is going to get factored out, and those are going to be simplifying it. So here we have one x plus 7, and we have another x plus 7. So per every two of the same thing, one of them is going to come out. So your answer is just x plus 7. So the answer to the square root of x to the second plus 14x plus 49 is x plus 7. So I'll zoom it out so you can see what I did. Okay, so here we have another example here of simplifying a trinomial and eventually taking out the square root. So here we have 3x to the second minus 60x plus 300. So in order for us to simplify that trinomial, we can factor out a 3, right? So you'll have 3 times x to the second. And then how many times does 3 fit into 60? That's 20 times, correct? So it's 20x plus how many times does 3 fit into 300 here? And the answer is 100. So now here's what we do. We need to do the factoring of this trinomial here, which would be again, we have to continue, right, writing everything out. That 3, don't forget to keep on bringing it down because it's part of the equation, right? So let's do the two parentheses that we need to do, that we need to use when we factor out a trinomial. And to review, we look at the second sign. If it's a plus, that means that both of our parentheses will have the same sign as the first one. So here we have x minus, and then what number times itself gives you 100, or what is the square root of 100? It's 10. So what we need to do is, again, employ the same methodology or the same way to simplify it. We look at what's inside of our square root symbol, and per every two of the same thing, one of them gets simplified out. So here in this case, we have x minus 10, x minus 10. So you guessed it, x minus 10 gets factored out, right, in parentheses, times the square root of 3, because 3, it's only one number, 3, inside of the square root. Thus, your answer is that right there. Okay, let's look at another example over here now. So here we have two square roots that are getting multiplied. So what we need to do is we're going to multiply 10 times 5. That gives you the 50 here. And then x times x to the second gives us x to the third. and then y to the second and y to the fifth. I'm sorry, y to the second times y to the third gives us y to the fifth, right? Now we need to simplify so that we're able to get a to simplify this the square root here. So here what we can do is the following. Look, 2 times 25 gives us 50, right? And then this is 5 times 5. So inside of our square root we're going to have 2 times 5 times 5. Here we're going to have 3 x's, right? 1, 2, 3. And we have 5 y's, so we'll just expand it here. For the y's, we can just do, it simplifies as y and then y to the fourth, and this y to the fourth can be broken down as y to the second, or you can expand 5 y's here. It's completely up to you. I'm going to use the y to the second because I'm going to be a little lazy and I don't want to write too many letters. So it'll be y to the second times y to the second times y. Okay, and we have to employ that same method again, right? For every 2 of the same thing, one of them is going to come out. Okay guys, sorry I had to put the video on pause because I had to get another marker because this one's dying out, the black one. So again, per every 2 of the same, one comes out. Is how many 2's do we have inside the square root? Only 1. So chances are that one is going to stay inside our square root here. Per every 2 of the same thing. So there's a 5 and a 5. One of them comes out here. For the x's, similar situation, right? There's 1 and 2, 1 comes out, and that x gets placed inside. And for the y's, there's 1 y to the second, 1 y to the second, so a y to the second comes out, right? And that y remains inside. Okay, I got a little carried away here and I made it too big. Okay, so our final answer is going to be 5x y to the second times the square root of 2xy. That is our complete answer here. Okay, I'll zoom it out so you guys can see.